Today we're going to be talking about operations in scientific notation, namely multiplication and division. We're going to start with multiplication. We see that we have 3 times 10 to the 5th times 8 times 10 to the 4th. If we remember the commutative property of multiplication, we remember that if things are being all multiplied, or basically all multiplied or divided, we can rearrange them however we like. And what that means we're going to do is we're going to take the normal numbers and we're going to rearrange them so that they're next to each other, and we're going to rearrange so that the 10 to the exponents are also next to each other. What we're going to then rewrite it as is 3 times 8 times 10 to the 5th times 10 to the 4th. This makes it a little bit easier to understand what's going on here. So then we have 3 times 8, which just becomes 24 times, and this is where we have to remember our rule of exponents. They have the same base, they're being multiplied, which means the exponents are added. So then we take 5 plus 4, and we get 24 times 10 to the 9th. You might think, oh, that's great, we're done. But we're not, because this is no longer in scientific notation, and we need to rewrite it so that it is. So going back to what we did yesterday, we can remember that if we're taking the secret hidden decimal at the end of 24, and we're moving it to the left, if we're making it smaller by a factor of 1, what we're going to do then is make the exponent bigger by a factor of 1. So our new answer becomes 2.4 times 10 to the 10th power. And now it's in scientific notation, and we have our answer. So we'll review here. We'll see that when we started out, everything was being multiplied or divided, meaning that we can rearrange it however we want. So we put the normal numbers next to each other, and we put the 10 to the exponents next to each other. 3 times 8, we just simplify those normal numbers by doing normal multiplication. The exponents, because they're being multiplied, and they have the same base, we can add. Once we did that, we had to make sure to put it back in scientific notation. When we talk about division in scientific notations, there are 2 different methods I'm going to show you. One of them is for easy divisions like this, where you can right away see that 8 can be divided by 2. What we're going to do is basically the same thing. What we're going to do is basically the same thing that we did with our multiplication. We're going to imagine that we're splitting up the normal numbers from the exponented numbers. So I'm going to rewrite it as 8 divided by 2 times 10 to the 8th over 10 to the 4th. When I complete just this left side here, 8 divided by 2 I already know is just simply 4. Now I remember that because these have the same base and it's being divided, instead of adding the exponents, now I subtract. I subtract positive 8 minus positive 4, which is simply 8 minus 4 equals 4. So I have 4 here from 8 divided by 2 times 10 to the 4th power. This is already written in scientific notation, so I don't have to do anything further to it. It's done. The second type of situation you're going to come across is one where I'm going to show you a little trick to kind of cheat the system. Here I see I have 1.8 times 10 to the 9th divided by 3 times 10 to the 2. Right away I see that if this number were 18, it would be easily divisible by 3. Unfortunately, it's not 18, but we can make it that way. Remember how I talked about increasing and decreasing factors and kind of balancing both sides? If I make this larger by a factor of 1, so I go from 1.8 to 18, multiplying it by 10, then I have to balance the other side of it by subtracting a factor of 1 from the exponent. So I have now 18 times 10 to the 8th, which is, you can see, no longer in scientific notation, but it makes our work a lot easier, divided by 3 times 10 to the 2. So in the same way, we split it up so that it's normal numbers versus exponented numbers, and we have 18 divided by 3 times 10 to the 8th over 10 to the 2. 18 divided by 3 is 6, and then I have, again, same base, it's being divided, so we subtract the exponents. 8 minus 2 is 6. So it's 6 times 10 to the 6th. And now, it's in scientific notation. Now let's say that you didn't actually want to do that. Let's say that you don't understand what I did here by increasing it by a factor of 10, and you just don't want to deal with that. You don't have to. You can do it the normal way, but then you're going to have to work a little bit harder to put it back into scientific notation. So here's what I'll show you. We can just go ahead and split it right now without doing any of that factor balancing. We can just rewrite it as 1.8 divided by 3 times 10 to the 9th over 10 to the 2. What you're then going to get is 0.6 times 10 to the 9 minus 2 to the 7. But again, that's not in scientific notation, so you're still going to have to do some factor balancing. This doesn't have a number in front of the decimal. This doesn't have one number in front of the decimal. So that means we have to move this decimal point over 1 or increase by a power of 10 to the 1. So basically we're adding here. We're making this number bigger by a factor of 10. That means we have to make this number here smaller by a factor of 10 in order to balance it. So then we'll get, just like we did with the last method, again we'll get 6 times 10 to the 6th. So either way, you're going to get the same answer. It really doesn't matter, but either way, you're going to have to balance a factor of 10 somewhere in there.